In this video, we're going to look at a couple examples of going from names to the structural formulas. Now, going in this direction is pretty easy because the name really just explicitly tells you what the molecule should look like. But in order to do these, you have to have the base names memorized. So you need to know that meth is 1 carbon, and pent is 5 carbons, and oct is 8 carbons, and so on. And then you also have to know the substituents. So fluoro, chloro, bromo are pretty easy. The harder ones are when you have like 3 carbon groups. You got to know the difference between propyl and isopropyl. And then you also have the 4 different butyl groups. If you don't know what those are, you need to be sure you go back to the textbook or the notes or some of the previous videos where we've got pictures of what those different substituents look like. All right, so looking at this example, I've got 2-bromo, 3-ethyl octane. So I think the easiest thing to do for these is to start with the base name, right? So I know it's octane, so I'm going to go ahead and make a 8-carbon chain, and then I'll put the substituents on it. So I've got 1, 2, 3, 4, 5, 6, 7, 8. All right, and then it doesn't matter which end I start from. I usually go left to right. And so I've got 2-bromo, so I'll go to the 2nd carbon and put the bromine. And then on the 3rd carbon, I'm going to put an ethyl group. So 1, 2. And so there's our molecule. All right, now we have 2,3-dimethyl pentane. So again, I'll start with the base name, and I'll draw pentane. So 1, 2, 3, 4, 5. And then I've got 2 methyl groups on carbons 2 and 3. So I've got 1, 2, and there's 2,3-dimethyl pentane. All right, now I have a cyclic alkane. In this case, I have cyclohexane. But again, I'll start with the cyclohexane, and then I'll put these substituents on. So cyclohexane is going to be a hexagon. So there's my cyclohexane. Now, which carbon is 1 doesn't really matter. Just for consistency, I usually start with the one on the top. So I'm going to put my 1-ethyl there. So I need 2 carbons. So there's my ethyl group. And then my isopropyl group will go on the 3rd carbon. And so I got to know, right, the difference between isopropyl and propyl. Right, so propyl is just I have 3 carbons coming straight off. The isopropyl is where I've got the middle carbon in the propyl group attached to the cyclohexane. So I'll have this guy coming out, and then for isopropyl, right, so I've got my propyl group, I've got the 1, 2, 3. If it's connected, if this guy had been connected, and so it had just been 3 carbons coming off, so the propyl would have just been 1, 2, 3. So if the propyl was in a straight line, it's isopropyl because it's the middle carbon in the propyl group that's attached to the cyclohexane.